This video will cover the following topics: prerequisites for IGMP snooping with multicast applications. Number 2, workflow demonstration of performing IGMP snooping configuration. And the last item, troubleshooting considerations. So the first item we really need to look at is we want to apply some time researching the respective multicast application manufacturer documentation. And this is really critical. With multicast applications, often there are specific requirements and or caveats. So this is something you definitely want to apply time researching in the pre-sales phase to make sure the selection of the different components and applications are going to function correctly. Also check to see if there's a qualified switch list. A lot of manufacturers that produce multicast applications for the pro audio video industry actually have a switch qualification program where they'll qualify switches, and they'll go ahead and also publish for the qualified switches configuration documents. Again, very critical. You want to basically control your risk exposure, and one of the key methods of minimizing your risk exposure is by seeing specifically which switches the respective multicast application manufacturer has tested, and then looking at the documents they produce for those specific switches as far as the configuration. Typically they'll include 2 key topics: the IGMP snooping configuration for pruning or controlling the multicast applications, and also Q-SYS configuration for quality of service. In this video, we're going to focus on the IGMP snooping. However, Q-SYS is also very critical. Most of the pro audio video applications have very tight tolerances regarding latency, jitter, and packet loss, and it typically tends to be exponentially tighter when compared to something like VoIP. Generally, with the pro audio video applications, we're dealing with microsecond domain from a timing standpoint. And when VoIP, we're dealing with millisecond time domain. So it's exponentially different timing domains. The other thing also to be aware is if the project involves multiple multicast applications. So for example, you have manufacturer A, and you'll be sourcing the audio digital signal processor, amplifiers, touchscreens, PTZ cameras, etc., etc. However, then you have manufacturer B. Perhaps you're going to be sourcing microphones, and then you have manufacturer C. You'll be sourcing the video streamer, so transmitter, receiver. You want to verify that there's no conflicting switch configuration information, because that can be a problem during the deployment phase and generally just supporting the solution. So this is something you definitely want to go ahead and see what type of configuration examples you can get from the respective manufacturers, and then you want to do a comparative analysis to make sure that the configuration examples don't show conflicting settings. And again, the easiest way to do this is to contact the respective multicast application manufacturers to get sample switch configurations regarding what switches they've tested, and if there's any items that are questionable as far as why certain things are configured when it's perhaps something that is opposite to the other manufacturer for the multicast application, they go ahead and request clarification for their respective multicast application, understand exactly why are they using a specific setting. So again, this is very, very critical. Often if this is a new venture, the multicast deployment for you, you may want to go in and see what partners are available, either IT partners like a Cisco certified VAR that specializes in multicast, and or a pro audio video dealer that again specializes on those respective multicast applications. goal is to really minimize risk of running into different problems and also minimizing the amount of time the deployment's going to take and effort. Number 3, the other key question to ask, is the multicast application registered or unregistered? Very critical. What I'll be showing today is actually an application that uses multicast registered, and you'll notice it's actually fairly easy from a configuration deployment standpoint, because once we turn on IGMP snooping and we have a switch selected as our query switch for the respective VLAN, there's really not much that needs to be done, and it's controlled in a very elegant fashion, the way the IGMP snooping mechanism works, the way the query works, the way the application joins the multicast group that it's interested in, and then the way it actually leaves the multicast group. That once it's finished, for example, if you're shutting down an application, it'll go ahead and generate a leave message. So it's very, very elegant. When we have application that's unregistered multicast, it becomes substantially more difficult. So this is something you want to understand, especially if you have a mix of both registered and unregistered multicast applications. That can potentially present some challenges in the deployment. The next one really applies very heavily towards video applications, specifically pro video transmitter and also receiver. Those devices typically, there's a large spectrum of different devices, but often what I see is most of those devices work somewhere in the 700 to 850 megabits per second range per each device. So you have a transmitter transmitting in that range, you have a receiver, and then often in projects you have multiple transmitters and multiple receivers. So generally, if you're dealing with a pro video multicast application, your links between switches should be a minimum of 10 gigabit. And sometimes that may not be enough. You may need to do 40 gigabit or higher depending on your situation. So something to be very careful of. I've seen a lot of folks get themselves in trouble not doing bandwidth estimations in a pre-sales phase of their project, only to realize the switches they've selected don't have enough bandwidth. Okay, number 5, what level of network performance, latency, jitter, and packet loss does the multicast application require for Q-SYS and or general network design? So this is actually very critical. As I mentioned earlier, with pro audio video applications, multicast applications, we're typically dealing with microsecond time domain. Again, that's exponentially tighter when compared to VoIP. So currently, if you have a network that's running VoIP and you have Q-SYS and you think that may be enough for a multicast pro audio video multicast application, you really want to do a pre-sales analysis. See if you can get some demo gear for a few weeks to test your network just to see if it's going to be able to offer the needed latency, the needed jitter, and also the packet loss. So again, we're talking about microsecond time domain, so it's very, very tight tolerances. Number 6, is the multicast application limited to layer 2 networks? So this is an area that if you're doing small deployments like a meeting room and the multicast is going to be application limited to really one switch that's going to be living in the meeting room area, and it's going to just basically be isolated there for the multicast side of things. Because just as a footnote, often the digital signal processors, like the one we're going to be looking at today, which is a Q-SYS Core 110F, most of them have typically at least 2 interfaces. Sometimes the larger ones even have more. And for most meeting rooms, assuming you're doing a meeting room, what will happen to minimize issues is you'll use one LAN port with a switch, and that'll be the multicast site. We'll call it LAN A. And so that's where you're going to have the AES-67, you have PTP-v2, you have QLAN, you have QDP protocol, etc., etc. And as long as you have IGMP snooping and Q-SYS set up correctly on the switch, typically you'll be in great shape. Then on LAN B side, they'll actually typically have the multicast disabled, and that interface will only really be used for managing the DSP, so you can do remote managing, and or for VoIP, like SIP registration, so you can also do telephony types transactions in a meeting room. So the key thing here is if you're doing a large deployment where it's not going to be isolated to one room, so for example, let's say you have a multi-story building, and each story in the building is going to be a separate IP subnet, i.e. separate VLAN, if you will. And the way most modern pro audio / video equipment is they'll have some type of synchronization mechanism. Very popular is Precision Time Protocol v2, PTP v2. And let's say that one of the devices you have, not the DSP, but let's say you have a peripheral, and that device for whatever reason must be the clock master. So one thing you need to be really careful is if you're going to have each floor on a different IP subnet, and you're going to have a device that needs to be the clock master because of a caveat of the device, you need to make sure that device that now is the clock master for all of the multicast devices that are using this PTP v2 clock mechanism as a source. Is that device going to support a layer 3 multicast PIM sparse mode routed network? So these are key questions to be aware of, because you can get into a very large project and run into a lot of problems without going from A through Z, making sure that all of the components support. If it needs to be full-blown layer 3 multicast, for example, supporting a network deployment of PIM sparse mode, then you need to make sure you check with all the respective multicast manufacturers that their multicast application, multicast device, does it support layer 3 multicast routed networks? What is the maximum hop count, etc., etc.? By the way, in this video, we're going to really be focusing more in a meeting room type of space. So the switches we'll be focusing on are small business switches, really focused to be cost effective, easy to deploy. So they don't support layer 3 multicast routing. Generally, if you want to do layer 3 multicast routing, you'd be looking at a Cat 9K, a Cat 3850, Cat 3650, or something similar from one of the other respective manufacturers. Typically, there's also an additional enterprise license that needs to be added. The configs, are more advanced. So for this specific video, we're really going to focus on just the concept of IGMP snooping, but in any case, just making you aware that there's additional items in the pre-sales phase you want to really hash out. Number 7, does the multicast application have specific requirements? Example, does multicast application need to be PTP v2 Grandmaster clock? I mentioned that a moment ago. So again, you want to investigate, are there any specific caveats? Is there a peripheral that for whatever reason must be the clock master? And if that device is not the clock master, it's just not going to work. So there are some caveats like that out there. And on the surface, they may not be apparent. And that's really where you want to, again, get in touch with a VAR or a pro audio video dealer, do a proof of concept, to basically filter out any of these kind of gotchas that might come up during the configuration deployment phase. Number 8, does the multicast application / device have other specific requirements? For example, PoE. More and more now, the video streamers are PoE devices, which makes them very convenient, especially if they're going to be attached to back of a large screen, up in the ceiling. It's much easier to do a PoE drop up in the ceiling, etc., etc. So you want to make sure if it requires very high power PoE, so for example like 72 watts, because it's 4K, 444 video, etc., etc. These are things you want to hash out to make sure, number 1, can a switch deliver that power per port, and what is the total power budget of the switch, depending on how many of these devices you're deploying. The other things might be flow control, touch controllers. if you're deploying them in environments that have high multicast, and certain devices may do certain types of interactions with multicast, sometimes they may have specific requirements, flow control or other requirements. Again, you want to look at the specific requirements, the documentation, config guides, any other type of release notes that the manufacturer has. By the way, the other thing I should mention is you also want to make sure you have updated firmware. So for example, on your switches, you want to make sure you update the most recent firmware. Also on the Pro Audio Video equipment, you want to make sure you update firmware, most recent firmware. If you're working with enterprise products, for example, on the Cisco side, there's something called suggested iOS XE releases on certain products. So that's probably the one you want to target, unless the Pro Audio Video manufacturer has other specifics. But what you want to avoid is you don't want to just go in and install the switch and leave the default firmware. Likewise, on the Pro Audio Video equipment, the default firmware on it, because you're really losing a lot of value through the life cycle of a switch, life cycle of Pro Audio Video equipment. There's a lot of updates, minor, major updates, enhancements, different types of fixes. So that's something you really want to hash out during deployment phase, and don't wait, because that alone can cause you a lot of headaches. Okay, so before we actually go into the configuration, and I'm going to show the configuration using the GUI, but I want to also show what the command line looks like. So our topology is very basic. We have switch 1 here. Switch 1 will be acting as the IGMP snooping querier. Switch 2 will have IGMP snooping enabled, but he will not be the querier because we only need one querier. So pretty simple. Since we're only doing audio, we just have a 1 gigabit link here. But as I mentioned before, if this was doing video, we would need at least a 10 gigabit link or higher. So be aware of that. In this case, we're just doing audio, so 1 gigabit is fine. We have a management computer. And a management computer basically is going to be managing the 2 Q-SYS cores using QTP protocol. And then basically between the cores, we have 3 primary traffic types occurring. QTP, basically, we have between the cores, that's how the cores discover each other, is using QTP protocol. And that's approximately 1 packet per second. It is multicast. And then for the clocking, as far as how the Q-SYS cores are synchronized, it's using PTP v2, Precision Time Protocol v2, and that's the purple dotted line right here. And then the actual RTP audio that we're streaming between the cores as our main traffic source. So this deployment, this would be the largest, the majority of traffic, is going to be AES67. So pretty simple example. And we're just going to focus on what do we need to do on a switch site to enable IGMP snooping for this type of deployment. And actually, there's not that much. So these switches are basically factory defaulted. The only thing I really added that's not specifically tied to the IGMP snooping config phase is I've put IP addresses, respective IP addresses on both switches from a management standpoint. So we have a .1 and .2, VLAN 1. Pretty straightforward, nothing special there. And then specifically from a IGMP snooping standpoint, on both switches, we're going to do this bridge multicast filtering command. So both switches have that same command, bridge multicast filtering. And then specifically, we're going to do IGMP snooping, IGMP snooping VLAN 1, and then IP IGMP snooping VLAN 1 immediate leave. This immediate leave is really required when you're doing video. In this case, I'm not doing video, but wanted to highlight it. So if you're doing pro video multicast application, when it comes time to change the multicast groups, i.e. channels, if you will, if you don't have immediate leave configured, most commonly what you're going to see is a delay. So instead of switching instantaneously, it'll kind of just hang there for a bit, a few seconds, 3 seconds, 8 seconds, etc., etc. And most likely there'll be pixelation or some type of distortion. it won't look good to the end user. So that's something you want to configure if you're doing Pro Video multicast application. But again, you do want to reference the respective manufacturer documentation. And then the left-hand side switches are switch 1. We're also making him the querer for the network. So we only need one querer for each respective VLAN. We only have one VLAN, so he is the querer. And then we're also saying in this scenario, we don't want to do any type of querer election. So we're just disabling the querer election. It does have that capability, but in this case, we're just going to say we want switch 1 to be the querer, and that's it. And then on the right-hand side switch, switch 2, the config is a little bit shorter. So IP IGMP snooping, then IP IGMP snooping VLAN 1, and then IP IGMP snooping VLAN 1 immediately leave. So this point of time, as far as the IGMP snooping mechanism for this deployment, we're pretty much ready. The one thing I would like to note is what I'm not covering in this video, but it's equally as important, is going to be Q-SYS configuration. So to not make this video super long, that is something I'm not covering, but when you look at the respective manufacturer switch configuration documents, that's what you'll find. Two key items they'll typically cover. One is going to be the IGMP snooping config, what we're really focusing on this video, and then the second item they'll cover as a main topic is going to be the Q-SYS configuration. Okay, we're going to go ahead and take a look at the actual application, the Core 110F appliance, and the Q-SYS Designer software. It is actually running right now, and if we take a look at the AES67 blocks, we'll see that we're receiving and also transmitting audio. So we have 8 channels of audio, AES67 we're transmitting, and also we have 8 channels of audio, AES67 that we're receiving. So this is one of the Q-SYS cores, and then the other Q-SYS core is going to be this unit right here. And again, we have 8 channels of AES67 audio that we're receiving, and also 8 channels of AES67 audio that we're transmitting. Right now we have the actual switch to factory default, the 2 switches. The only configuration that's been done on the switches has been the firmware has been updated to the latest firmware. And also we've given each respective switch an IP address for management. So right now we're going to take a look at the effects when IGMP snooping is not turned on and we have a multicast application running on a network. We're going to go ahead and open up Wireshark, and we're going to go ahead and start a capture here. We're just going to run a few seconds here. Okay. And if we take a look at this, we're going to just see from capturing approximately 4 seconds, so 4.4 seconds of capture time, we're at 10,496 packets. And what you're going to notice is a majority of these packets are actually multicast packets. So if you notice, the destination is 239, 224, and this is why it's very critical when we're deploying multicast applications that we have properly configured IGMP snooping, especially professional audio and or video multicast applications, because the network, the devices, the PCs, IP cameras, print servers, WAPs, IP phones, touch panels, etc., will be impacted. And if the packet rate is high enough, the multicast packet rate is high enough, and IGMP snooping is not properly configured, not only will the devices suffer from a performance standpoint, but more often than not, you actually see devices fall off the network, which definitely is a bad thing. So in any case, we're going to go into the actual switch itself. So right now the switch is factory default. And we're going to go under multicast. And the first thing we want to enable is this feature that is listed as bridge multicast filtering status. So we want to enable this. the next thing we're going to take a look at is enabling the IGMP snooping status. In this example, we're keeping things as simple as possible. So the switches only have one VLAN, VLAN 1, which is a default VLAN. And here we want to enable the IGMP snooping status for VLAN 1. If we're doing video, so in this case we're just showing an audio example, but if we were doing video, we would also want to enable immediate leave. So I'll just go to enable it as an example. But immediate leave in most cases is something for video. If you're doing video multicast, typically is a requirement. Reason being, as you're switching from different video sources, multicast video sources, if you don't do a immediate leave, there will be a delay and or distortion seen, which you don't want the actual user using the application to see different types of anomalies show up. So in any case, if you're doing video, most likely the respective manufacturer in their documentation is going to suggest the immediate leave option to be enabled. Okay, we're going to make our first switch be the courier. In this case, we're not going to enable courier election, so we're just going to keep switch 1 to be the courier, no courier election. The other item to be aware is if you do have the same make and model of switches and they support courier election, you could keep this enabled, and then the switch will elect one switch to be the actual courier. If you have a mix of different makes, models of switches, it is probably the best option to keep this disabled because there might be some questions as far as interoperability between different makes and models of switches, because certain switches may not support this option. So again, apply some time, take a look at the documentation if you have a heterogeneous environment with different makes and models of equipment to get an understanding if the IGMP snooping courier election option to enable it is feasible or not. In this case, we're going to use IGMP snooping courier version 2, which is what most applications today are based upon. And we're going to leave the courier source IP address as auto. Okay, then we're going to look at the status here. So we'll notice VLAN 1. And the key thing here is going to be the operation. So we want to make sure it's operational enabled. Great. And then also the courier status. We want to also make sure it is enabled, which it is. So those are the two key items you want to take a look at here. And then we notice that the courier address is the address of switch number 1, VLAN 1. Great. It's version 2. Great. As we talked about a few moments ago, right now we'll just keep the IGMP snooping courier election disabled. Then we're going to save this for switch 1. And then we're going to go to switch number 2. Okay. Bridge multicast filtering status is enabled. Okay, we're going to enable the IGMP snooping status. And we're going to edit VLAN 1. Okay, we're going to enable the IGMP snooping status for VLAN 1. If we're using video again, we would want to make sure the immediate leave for IGMP snooping is enabled. We're not going to enable courier on this switch because switch 1 is already courier, and we're going to leave the rest as is. We're going to hit apply. Okay, so let's take a quick look at this. So the IGMP snooping status is operational enabled. Great. Okay, we're going to go ahead and apply this, and we're going to go ahead and save. Okay, now we're going to go back to our application here to make sure everything's still functioning. Okay, so this is us transmitting from one of the Q-SYS cores, the AES-67 multicast audio traffic, us receiving the AES-67 multicast audio traffic from the other core. Okay, and then this is the other Q-SYS core, us transmitting the AES-67 multicast traffic, and then us receiving the AES-67 traffic from the other Q-SYS core. Okay, now we're going to go in and do another capture. And we're going to let it run again another 4 seconds or so. And you notice there's quite a big difference in the traffic. So we are interacting with the Q-SYS cores from the application standpoint. As you notice, we had the graphs that show the actual audio levels a few moments ago, so that actually does generate traffic. But if you look at the actual destination IP address, that is going to be actually of our PC. So as far as multicast traffic, there's going to be very little multicast traffic, because right now our PC has not joined a multicast group as far as the AES-67 audio. Also, there's going to be other multicast traffic. For example, for PTP version 2, PC does not participate in that. So if we go up to statistics and we go to UDP multicast streams, so the two multicast groups you see here is what the actual Q-SYS designer software uses for discovery of the Q-SYS cores and other Q-SYS products, called QDP protocol, and that's the 224.0.23.175. So this would be expected traffic. So right now this is the only multicast traffic we're seeing. And if we were to actually turn off the application, so let's go ahead and let's temporarily jump out of those applications. So I'm going to go and save the work here. Okay, and then let's go ahead and jump out of this application. Okay, we're going to do another capture. We're going to let it run for a few seconds. Okay, we're going to go and stop it. We're going to go up to statistics and UDP multicast. And if you notice, at this point of time, there's zero multicast traffic that's reaching our PC. In the background, there's definitely AES-67 traffic going between the two Q-SYS cores. There's PTP v2 traffic going between the two Q-SYS cores, and there's also QDP traffic going between the two Q-SYS cores. So there is a lot of multicast traffic occurring in the network. However, the PC currently is seeing zero of the traffic, and the reason is currently the PC has not joined any of the multicast groups. And the multicast group it had joined, which was for QDP protocol, it actually went ahead and disjoined that multicast group. So the switch or the switches were notified that this PC no longer wants to subscribe to the respective multicast group for QDP. Thus, it's getting no multicast traffic. So this is the efficiency with multicast and IGMP snooping when properly configured. It does offer a lot of scalability. It allows you to have one-to-many, and the one-to-many architecture is based upon subscribers to the multicast group. Okay, we're going to go ahead and take a look at some of the other items within the actual switch related to IGMP snooping. So we're going to take a look at what is called multicast router port. In this case, we know that switch 1 is acting as the IGMP snooping query switch, and the actual port that connects between these two switches, so this is switch 2. Port gigabit 8 is the actual switch that goes to, is the switch port that goes to switch 1, and that's dynamically been identified here as the multicast router port, which is correct. So the other thing we can take a look at here is going to be an option called forward all. By default, the CBS switches have this disabled, so if you notice it's none. And then the other item also would be unregistered multicast. By default, it is forwarding unregistered multicast. This is a critical item to consider. In this specific multicast application we looked at with Q-SYS cores, it is a registered multicast application that it leverages, which makes it very elegant as far as multicast deployment, IGMP snooping. As you noticed from the config we did, it was very quick, simple, and it functions as it should, as you noticed from the Wireshark captures we performed. Unfortunately, not all the applications that leverage multicast use registered multicast traffic. There may be certain applications you run across that is using unregistered multicast, meaning the respective device that wants to join the multicast group never is going to actually make an announcement that wants to join the multicast group and or leave the multicast group like we saw earlier. So in that case, you would basically forward that unregistered multicast traffic. The big negative is you would need to manually know which ports to forward the multicast traffic and also which ports to filter the multicast traffic. So it is something that you do want to be careful of. If you're working with a deployment that has a mix of both registered and unregistered multicast traffic, that's when things can get more complex, because as you notice, the registered multicast application, fairly straightforward. Few little configs that we looked at a few moments ago that you perform and you're pretty much set. With the unregistered multicast traffic, you would have to apply time identifying on which specific respective ports the unregistered multicast devices live on. So one of the things you can actually take a look at is going to be Discovery CDP, and you can look at CDP neighbor information. So in this case, this would be typically Cisco devices, although there are third-party devices that also support Cisco Discovery Protocol. If you remember earlier, we spoke about that port 8 from this switch goes up to switch 1 that's acting as the IGMP snooping query, and how this switch was able to automatically detect that that's the M router port. Well, another way to validate that would be going either under CDP neighbor information, and we'll look at LDP neighbor information here in a few moments, but this kind of verifies gigabit Ethernet 8 is going up to switch 1, and switch 1, as we noticed a few moments ago, is being identified as the M router port. In instance, gigabit 8 goes to switch 1, i.e. M router port, because that's where the IGMP snooping query lives at, on switch 1. But in any case, as you're plugging devices into your switches using the CDP neighbor information and or LDP, link layer discovery protocol information, makes it very easy to identify which respective switch port what devices live on. This does assume that the devices are leveraging LODP and or CDP protocol. So here we see again gigabit Ethernet port 8 is going up to switch 1, and we looked at that a few moments ago as far as that being the M router port dynamically identified. And then in this case, it is also telling us the LDP information we learned from switch 1, that on switch 1 it's actually gigabit port 10 that it's plugged into. If the devices do not support LDP or CDP, then the other option would be taking the actual MAC address of the respective device and identifying as what switch port and or what switches that respective device lives on. using the MAC address. So fairly easy. We go under MAC address table, dynamic MAC addresses will be listed here. And even if you have multiple switches, let's say you prefer using command line, you can do show MAC add from switch 1 to switch 2. Let's say the actual MAC address is on switch 3. So you log into switch 1 because you're not sure what switch that respective MAC address lives on. You do show MAC add. It shows that the port that it's being dynamically learned on is the uplink port that goes to switch 2. Okay. Log into switch number 2, SSH to it, and then you can do again show MAC add, and again it shows switch 2, uplink port that goes to switch 3 is where the MAC address lives at. Okay. Then you SSH over to switch number 3, do the same thing, show MAC add, and then you can identify what specific respective port the device lives on. So there's a couple different techniques we can actually leverage here to identify where certain devices live at if we're dealing with an application that does not support registered multicast groups. But that's something definitely you want to analyze during the pre-sales phase to understand if the application is registered or unregistered, because if it is unregistered, as you notice, it is going to be substantially more work that you'll have to do, and or it can cause some complications depending what other multicast applications might also be deployed. Okay, the next thing we can take a look at is within the multicast section of the switch, we can go down to multicast group, and we can look at what multicast groups have been learned by the actual switch, the IGMP snooping. So this first one here, the 224.0.1.129 is for PTP v2. Very commonly used in a lot of pro audio deployments. QLAN, AES67 are some examples. There are some other things related to Q-SYS that are also tied to this. Since this video does not focus towards Q-SYS, I won't go into it in this video, but in any case, PTP-v2. Then the next one's going to be QDP, Q-SYS Discovery Protocol, that is 224.0.23.175. And if you remember the first Wireshark we took before we enabled the IGMP snooping on the actual switches, and we were just capturing the traffic that the PC was seeing, that the AES67 traffic the PC was receiving at that point of time, since no IGMP snooping had been enabled on the switches themselves, was 239.69.58.61. So this is another way to check if things are not functioning the way they should. Is the IGMP snooping traffic or the multicast traffic registering to the IGMP snooping that you're anticipating? In this case, we are seeing that it is functioning as it should. Next, we're going to go ahead and take a look at the actual application Q-SYS Designer software. And specifically, we're going to take a look at the AES67 transmitter block. So we'll double click on this. And one of the things we'll notice is this actually discloses what specific multicast group it's actually transmitting the AES67 audio on: 239, 69, 58, 61. It shows that it's enabled stream main AES67-TX-1 network buffer default, and it's connected to LAN A. Okay, next thing we're going to take a look at is going to be the join and leave functionality of IGMP snooping, specifically the clients or nodes that want to participate, either receive or transmit different type of multicast traffic. So in this case, what we're going to do is we're going to go ahead and start a packet capture on the PC. Currently, the Q-SYS Designer software has been shut down on the PC. We're going to go ahead and do a display filter of IGMP, and we will go ahead and actually start the application, a Q-SYS application. So what I'm going to do here is I'm going to temporarily just kind of put this off to the side here, and we're going to go ahead and start Q-SYS software so you can see exactly what the effects are. You're probably seeing in background. So let me minimize it just for a moment. So if you notice, there's actually a membership report generated for Multicast group 224.0.23.175, and that's actually used for the Q-SYS or QDP, Q-SYS Discovery Protocol. So we're going to go ahead and load from one of the cores, configuration. Basically, the application is attaching to the core itself. We can look at the core status here. And we'll go back to the actual IGMP snooping within Wireshark. So let me maximize this here. So when I launched the application, the PC generated a IGMP membership group report for group 224.0.23.175, which is for the QDP protocol, Q-SYS Discovery Protocol, which the Q-SYS designer software or application uses for discovering Q-SYS devices, and vice versa. The Q-SYS core use that actually for discovering different type of Q-SYS peripherals. So it's a fundamental building block of the Q-SYS architecture. And if you notice, actually our switch number 1, which is 192.168.1.1, it generated a IGMP snooping membership query, and then typically within the next 10 seconds the respective device that wants to be part of a specific multicast group should reply back to the switch in effort to notify it that it still wants to receive specific multicast traffic. So in this case, my PC, which is .99, it's responding back to the general query message from the IGMP snooping querier on switch number 1 that it wants to continue to receive multicast traffic for group 224.0.23.175. So this will be repeated every so many seconds. Typically it's somewhere between 60 seconds to 2 minutes. Okay, we just got some more. So we had another general query sent by the IGMP snooping querier. And then again, the PC that's running the application went ahead and responded back. So let's go and let's turn off the Q-SYS application and see what happens. If you notice, what it just generated was an IGMP v2 leave group message 224.0.23.175. So this is telling basically the network, the switches, that this PC no longer wants to be a member of multicast group 224.0.23.175, which is for QDP protocol. The other item you can actually leverage, and this typically applies more towards video multicast deployments, troubleshooting issues, is take a look at the actual port utilization. So for example, if you go to status statistics, port utilization, you can take a look at the interfaces, transmit utilization, receive utilization. Right now we have very limited amount of audio channels, so the usage is very low. But typically for video, you have to be very careful. Generally, if you're going to be deploying Multicast Pro video applications, video transmitter, video receiver, most of those generally work in the 700 to 850 megabits per second bandwidth usage level, which can be quite high. And often they're deployed more than just a pair, meaning most projects you'll have more than just a transmitter receiver. So generally when you're working with pro video multicast based applications, your interfaces between switches should be a minimum of 10 gigabit and possibly even higher depending on the quantity of the transmitter receiver devices. Also, there's variations as far as compression algorithms, etc., etc. So this is the area you can very quickly run into different types of predicaments. In any case, go ahead and leverage the port utilization, and you want to basically make sure you're not hitting into the 90%, 100% usage, because that will definitely cause issues. The other thing also I should mention on the web interface on the CBS switches, and this also applies on the SG series, is always make sure you're selecting advanced, because if you don't have advanced selected and it's only basic, there'll be a number of different items that won't be visible. So just a quick tip. The other thing I was also going to mention is often applications will have some type of mechanism to tell you what the actual usage is, bandwidth usage or estimation. So we start off with only having 8 transmit AES67 channels and 8 receive AES67 channels. That was actually quite low, and I wanted to actually generate some statistics on the interface usage page. So what I did is added another 8 transmit AES67 and also another 8 receive AES67. So within the Q-SYS designer software, if you go to check design, this will actually show you an estimated as far as input network bandwidth usage. This is estimating roughly 28 megabits per second of bandwidth usage, and then the output network bandwidth usage, 28 megabits per second. So definitely, if the multicast application offers any type of tool set, especially in a pre-sales phase, you want to really estimate what the bandwidth usage is. And generally what I find as a good rule of thumb is if you're starting from day one with a project and you're already using a majority of the bandwidth, that's typically not a good idea, because things often do change in a project which are not within your control. They're beyond the control that you might have. There may be a change in a customer's environment. There may be product changes, etc., etc. So generally, you want to estimate your bandwidth not to exceed about 60% of the available bandwidth on the network. And you want to leave at least another 20% of headroom. And then you typically don't want to exceed 80% total capacity. So if you have a 10 gig link between 2 switches, from day one, you should not be exceeding 6 gigabits of traffic across the link, because you really don't have any headroom for growth. And likewise, as you grow, you should not really exceed 80% of the 10 gigabit or 8 gigabit per second available bandwidth. So these are just some things to be aware. Again, typically more applicable towards multicast video for transmitter receiver video applications, but something I do see often folks get themselves into trouble. Okay, we're going to go ahead and take a look at this diagram here just to revisit the concept of unregistered multicast traffic and why it can be a big issue. So on the left-hand side, we have 2 transmitters, Pro Video transmitters, and each one of these we're saying is approximately 800 megabits per second of multicast bandwidth for the video. And so that's going to equate to 1600 megabits per second. As I mentioned earlier, for video deployments, we should have a minimum of 10 gigabit Ethernet as a starting point. And if we're doing a larger quantity of Pro Video transmitter receivers, then we may need to do higher capacities, 40 gigabit. Nowadays, there's also offerings for 25, 50 gigabit, higher end switches, 100 gigabit, 400 gigabit, etc., etc. But in any case, in this example, if this was unregistered multicast, the issue that we would run into is obviously we have more enough capacity on the link between switch 1 and switch 2. This is 10 gigabit. And the bandwidth we mentioned we need is 1600 or 1.6 gigabit, so that's no issue between the switches. The issue you're going to run into is going to be on the devices that are actually receiving the unregistered multicast. And what's going to happen is these devices are typically 1 gigabit links. So now the device is going to be receiving over 1 gigabit, and it's just going to have massive packet loss. Right where the device plugs into the switch right here, at 1 gigabit, that interface cannot support 1600 megabits of traffic. So this is why I mentioned it's very critical at the pre-sales phase to really understand the application of multicast application, especially on the video side. Is it using registered or unregistered multicast? And then take it a step further. If it's unregistered multicast, so let's say you look at the data sheet, you contact the respective manufacturer, and they generically say, yes, it's unregistered multicast, you want to dig even deeper. What specifically is unregistered multicast? Is it the actual discovery packets the Pro Video solution use it? Is it management packets, which might be a combination of both management discovery, or is it the actual media, the actual video media, the RTP? If it's the actual video media, then scalability, it's simply not going to work. Because then the question will be is how do you control that traffic on the receiving end? Because now if the ports are configured to forward unregistered multicast, we're just going to be exceeding the 1 gigabit ports that are interfacing to the Pro Video receivers, and obviously that's simply not going to work. If you just have one transmitter and one receiver, or one transmitter and multiple receivers, then obviously it's 800 megabits per second. It would not be a big deal, assuming you have 10 gigabit link between, and you're filtering or not forwarding unregistered multicast to the other respective devices, etc., etc. But this is really where, for most deployments, what customers are looking for typically, again, referencing meeting rooms, is they'll typically have a couple different sources, and then they'll have transmitters, and they'll have a couple different receivers or output devices, different displays, etc., etc. So this is really where you want to clarify, one, is it registered or unregistered multicast? If it's unregistered multicast, you want to dig deeper and you want to understand what specifically is unregistered multicast. Is it just the discovery and or management, or is it the actual RTP traffic, the video traffic, the traffic that generates the 800 megabits per second per each transmitter? The other thing I should also clarify is there's different levels or different product categories as far as the video transmitter receiver solution from the different respective manufacturers. So there are higher end video transmitters, more premium versions, if you will, higher cost, that do offer flexibility, such as you can go from constant bit rate to variable bit rate. You can also adjust the megabits per second. So that's good. So you could potentially squeeze this number down, this 800 megabits, to a lower number, again, depending on resolution, frames per second, color bit depth, etc., compression algorithm, so on and so forth. But be aware that often what I've noticed is where customers run into a problem is where budgets are very limited. So they'll go ahead and select the most cost-effective video transmitter receivers they can find, and unfortunately those are typically the ones that offer very little to no adjustment. So they are typically at pretty high numbers, or like 700 to 850 megabits per second. And then again, because budgets are very limited, they may not do a 10 gigabit link between the switches, and as you can tell, that is going to equal a problem right there. So next one we're going to take a look at here is going to be one that is actually using registered multicast for the solution. So again, we're focusing on Pro Video solution transmitter receiver, and we're stating here that we have a total of 5 transmitters. So on the left hand side we have 5 Pro Video transmitters, and they're going to be generating 4,000 megabits per second of traffic, video multicast traffic. Again, we're assuming each one is 800 megabits per second. And so we know, as we talked about earlier, 10 gigabit Ethernet should be the minimum link speed between your respective switches anytime you're doing pro video multicast type of application. So we have switch 1 from switch 1 to switch 2, 10 gigabit, and likewise switch 2 to switch 3. And where the actual elegance comes into play here is where all three switches have IGMP snooping enabled, so that's a requirement for multicast. And what we're going to do is basically, and let me just take a step back. If IGMP snooping was not enabled on these respective switches, multicast basically would act like a broadcast that would be forwarded to all the ports. So it just really wouldn't be scalable. You know, the entire network suffered. But going back to our discussion, so all three switches have IGMP snooping enabled. We're going to be using version 2, most common version used today for multicast applications. And switch 1 is going to be the IGMP snooping querier, kind of what we did earlier in examples. So what's going to happen is anywhere from 60 seconds to 2 minutes, switch 1, which is the IGMP snooping query, is going to send out a general query message out to the network. The respective devices, in this case the receivers, are going to respond back. They want to go ahead and continue receiving the multicast groups for the respective video that the receiver's on, i.e. video channel, if you will. And the elegance of the solution is that the multicast traffic, so let's say the receiver right here wants to get video, the multicast video from the transmitter right here. He's going to let the network know that I'm looking for this specific multicast group, and then that multicast group traffic is going to be propagated all the way from switch 1 to switch 2 and the respective switch port where this pro video receiver lives at. If, for example, the pro video receiver on switch 3 also happens to want to receive the same multicast traffic, that traffic's already being propagated to switch 2. And basically, the bottom right-hand side pro video receiver is going to send a join message, and this switch is going to actually propagate that over to switch 2, and then it's going to start forwarding that multicast traffic all the way switch 3, and then to the respective port where this pro video receiver is living on off of switch 3. So it gives us a lot of scalability and also intelligence in the network of using applications, multicast applications that are based upon registered multicast, because you're really letting the network do the work. You have each switch configured as with IGMP snooping. You have one respective switch for that VLAN configured as the IGMP snooping querier, and then every 60 seconds to 2 minutes is sending out a general query message, and then within the next 10 seconds it's getting responses from the different respective multicast devices, what respective multicast groups they want to continue receiving packets for. So this actually works very well. It's very scalable, but again, it's very critical in the pre-sales phase that you hash out. Is this all going to be using registered multicast? Yes, great. Then you know your work's going to be much more straightforward. If it is not registered multicast traffic that some of the applications are using, then you want to really figure out how much bandwidth is that unregistered multicast traffic going to generate, because it can be a big problem potentially. Okay, we're going to go ahead and wrap up this video, and I'm going to end it by retouching a couple different things we talked about at the very beginning of the video. The reason is these are items that, again, you can get yourself into trouble fairly quickly, specifically from multicast application deployment. So I just want to highlight them again, hopefully to minimize any type of issues that you may run into future multicast applications. So again, these are things that we really want to hash out during the pre-sales phase of our project, basically before any equipment's purchased and or selected. And really we should consider this kind of a pre-quest. So we want to go in and research the respective multicast application manufacturer documentation. Very critical. because a lot of the manufacturers have applied a lot of man hours in doing research and development to understand what specific components in this specific topic would be switches would be qualified based upon the requirements of the multicast application. So this is something you definitely want to leverage as much as possible, and also the switch configurations that they used for the actual switch testing to see exactly what parameters they configured, also if there's any caveats or limitations for their multicast application as it relates to specific switches and or other multicast applications. And then number 2, if your project involves multiple multicast applications, verify if there's conflicting switch configuration information when compared to the different manufacturers. So if you're seeing example configurations and there's differences for the interfaces or IGMP snooping, etc., then you definitely want to contact the respective multicast manufacturers to get clarification. Why is there a specific configuration requirement either on a switch port level or something that's more global regarding IGMP snooping, etc., because there could be specific caveats respective to the multicast application that it requires, and it may be in direct conflict with the other multicast application. And in that case, the combination of the 2 or more multicast applications may not actually work as you intend in a deployment. So this is something that we definitely want to try to hash out in the pre-sales phase. We spent a good amount of time talking about registered or unregistered multicast applications, and obviously this is a big deal, especially when we're talking about multicast video. So this is something you definitely want to have a really good idea before starting your multicast project. If it's focused on video, is it registered, unregistered? If it's unregistered, you really need to apply time and analyze what is the actual bandwidth usage going to look like, and is it realistic based upon the amount of transmitters and or receiver combination you're going to be deploying for pro video. And this also ties into number 4 here. You know, how much bandwidth is the actual multicast application going to require? And one item I did not talk much about that I should mention is, please be aware there is quite a big jump when you're going from 10 gigabit up to 40 gigabit. There's also newer technologies support 25 gig and 50 gig, but you definitely want to see if it's copper based, you know, Cat 6A, Cat 7, what specific cabling did the respective manufacturer test with the higher gigabit Ethernet standards, and how many insertion points and patch panels are permitted. Likewise, often when you're going from 10 gigabit fiber to 40 gigabit fiber, we're going from what we're used to, like a LC connector, transmit, receive, fiber, optic cable, either short haul or long haul, single mode versus multi-mode. Multi-mode basically indoors, shorter distances. Single mode typically outdoors, longer distances. But when moving to 40 gigabit, often it's going to be an MPO type of connector that has actual multiple fiber strands within one connector, and often customer infrastructure may not be prepared for 40 gigabit. There are options on some of the switches, like on some of the Catalyst and also Nexus, called bi-die optics, which allow you to use the same type of fiber you typically would be using with 10 gigabit, but to do 40 gigabit. But these are finite details you definitely want to look at during the pre-sales phase to clarify all the way from the physical layer of the OSI model all the way to the application layer, to understand if there's going to be any major forklift upgrades that are needed infrastructure to be able to deploy the multicast application, specifically if it's video, because the bandwidth requirements, as you notice, can be very, very high. The other item which we did not really focus on is going to be QoS, but in any case, what level of network performance, specifically latency, jitter, and packet loss, does the multicast application require for QoS and general network design? So this is something to keep this video within reason I did not really go into, but please keep in mind that most pro audio video applications are working with a microsecond timing domain, where VoIP, if we compare it to VoIP, it's milliseconds. So we're looking at exponentially different timings. So this is, again, something you can run into a lot of problems if your network cannot meet the latency, the jitter, and the packet loss requirements of the pro audio video application. So you want to spend some time, again, in the pre-sales phase, if you can get some demo gear from the respective pro audio video manufacturer and do some proof of concept testing. That would really give you a pretty good idea. Is it doable? Does the network need to be tuned, or is it totally not going to work because of some type of performance and or bandwidth issue that you uncovered during the proof of concept testing phase? The other one is going to be, is the multicast application limited to layer 2 networks? What I focused mainly in this video is really examples that really assume that you're only going to be doing a layer 2 deployment, i.e. meaning it's within the same VLAN or within the same IP subnet. With larger deployments, obviously multi-story buildings, campus networks, we have multiple buildings within a campus, and then each building and or floor of a building is going to be a different subnet. If you're going to have a multicast application needs to traverse between buildings or between floors, it would need to be able to support a layer 3 multicast routed network. Typically PIM sparse mode is used. Those would be higher end switches, as I mentioned earlier, Cat 9300, Cat 3850, Cat 3650. Then appropriate enterprise licensing needs to be also purchased, and the config is going to be more advanced. The one thing also I should warn you is, due to the network performance requirements for the latency, jitter, and packet loss, typically routers don't yield the needed performance regarding latency, jitter, and packet loss for a lot of the pro video and audio applications. Typically has to be ASIC based, a switch. So just keep in mind, if you have a campus and you're doing MPLS between the different points in the campus, that may not meet the requirements, just as a footnote. So again, proof of concept with actual real equipment, real multicast applications would be highly recommended. Number 7, does the multicast application have specific requirements? Example, does the multicast application need to be PTP v2 Grandmaster clock? And that's something that, as I mentioned earlier in the video, you do have to be careful, because there are certain devices, they're not even core devices, meaning they're not the DSP, they're like a peripheral device, that for whatever reason they have some type of caveat where that device needs to be the PTP v2 Grandmaster clock, which kind of seems odd, because normally when you think of a PTP v2 Grandmaster clock, you're thinking about a really big box in the core of the network, high availability, potentially multiple power supplies, etc., etc. So this is something that can be hidden, and this is again why proof of concept in a pre-sales phase is very critical, and also working with appropriate partners. Cisco certified partners that focus on multicast applications, VARs, value-added resellers, if you will, pro audio video partners or dealers, if you will, that again focus on multicast applications. Those are very critical, value-added folks, and have a lot of experience with different applications. And if you're an end-user customer, you may want to go and investigate in your area who's out there that can work with you on a project. And then you can request basically from them to basically write up a list of what's going to be required for the project, billable hours, because a lot of these things I'm talking about here are billable hours. So These are all things that you want to have written up in a statement of work, so you know exactly in the pre-sales phase what type of proof of concepting, what type of network analysis needs to be done, etc., etc. And again, these are all, you can think of them as insurance policies to minimize risk in your project. And then the last item here, does the multicast application / device have other specific requirements, PoE, flow control, etc., etc.? Yeah, so definitely, you know, this is, again, ties into the proof of concept, because you may hash out everything with the key components or your video streamers, you know, transmitter receiver, your audio DSP, but then you also may have some multicast wall plates or touch panels or other devices. They may have very specific requirements. You also want to do some testing with those peripherals just to make sure there's no surprises at the end of the project when you're trying to close everything out and, you know, do a checklist that everything works fine. So hopefully this gives you kind of an exposure to some of the things when working with multicast, specifically IGMP snooping configuration example. And I think you'll agree, as far as the actual steps for the IGMP snooping configuration, it's fairly straightforward. There's not much to it. However, what typically makes multicast topic more complicated is there's a lot of potential other caveats, as you notice, other potential pitfalls that one might get into. So this is really, I can't stress enough, in the pre-sales phase, you definitely want to apply enough time and do the proper proof of concept and also get the proper folks involved to minimize any types of surprises. Hopefully this video helps you. Thank you very much for watching this video. I know it's been a long video, but I wish you the best in your multicast project, and good luck. Thank you very much.